Here we have a very simple electric box. Here's your main incoming power. It's going to go right in there. Standard Schneider relays, little controllable transformer. Those are your inverters for the work head, for the wheel head. That there's a little AC to DC converter, and that's used for the tachometer for the wheel head and the work head. Alright, when you turn the power on the back panel, you'll see you have your indicator light here. That shows you do have power. Now you want to kick out your e-stop. Now your inverters are firing up. And next thing you want to do is turn on the hydraulic. Without that running, nothing else is going to run. Okay, now that we've turned that on, this is the rapid feed. Which that's going to move the wheel in and back. And you can see that's on manual right there. Getting in the middle, these are dead. Nothing happens. When you're on here, you're going to move in. Oh yeah. You're going to move in 50 millimeters and then going out, that'll get it going out 50 millimeters. Here you have the spindle on. And this is the RPM range. These are the tacks for both the wheel head, that's the work head. Right now we have it with a 30-inch wheel in there. You're maxed out at 820 RPMs, which is 33 meters per second. So you got to be a little bit careful about that. The machine can go higher for that 24-inch wheel that you wanted, and you can get it up to over 1100 RPM max. We're going to dial this down to the maximum for that 30-inch aluminum oxide wheel. And this is the spindle on. And you can adjust this on the fly. And you can hear that changing. But 820 is the max recommended for these type of wheels, 30-inch diameter. And then turning the spindle off is just as easy as hitting that. Yeah, the RPM range for the work head on this machine was 25 up to 160 or so. We'll kind of get it down in the middle of the range for this demo. This position is off here. This will have the work head on. And to get it started, you move it a little more. And when you move the wheel back, that'll turn it off. And if the wheel, this is a note, if the wheel is not back at home and you turn this on, the spindle will go on as if you're still working on the workpiece. This whole system with the hand wheel here, turning it on and off only works when the wheel is back in the home position. I'm ready.
Good.
Come on.
So with the wheel not home, when you turn that on, the workhead will come on. So you see, unlike if it was home, it wouldn't come on until you engage it. But with the wheel head already not home, it comes on with the switch. The coolant's going to work just like the wheel head did. Off, on all the time, or in auto, when the spindle leaves home, it will come on. When it returns home, it shuts off.
This is the gearbox for the manual movement of the table. This is where your hand wheel goes in, and you will have a gear on the back side of that handle, and it meshes with this gear, but this gear moves in and out of the way when the hydraulic is engaged or not engaged. And that's why when you engage the hydraulics here, this is dead. Now you see hydraulic is on now, everything's moving, and this is freewheeling, not doing anything. But then when you take the hydraulic off, now you're moving the table mechanically. And these valves here, these are just for the dwell at the end of the stroke, left and right. And this controls how fast your table moves when your hydraulic is on. And then over here is a rapid override. And that uses a different valve, part of the same hydraulic system, but uses a different valve when you want to use a rapid. And you want to use that very sparingly, maybe just when you're setting up a part, but use that sparingly. And these are the dogs, which change the direction. This shows the air assist for the work head. Got to loosen up the bolts on the front there. This is the air assist for the tailstock. And you have to loosen those bolts and tighten those bolts. And it's very critical that you make sure the ways are very clean before using the air, because you don't want to get any swarf underneath the way surfaces. This table dresser is most often used when you just put a new wheel on. It is quicker, and then once you have a workpiece that's already between the between centers, you can't really use that dresser anymore. So then you're going to use the dresser that is on the tailstock. This oiling system here contains both the hydraulic oil system, which is down on the bottom, and that has a heat exchanger to help with remove some of the heat. And the one up top here is the oil for the hydrostatic lubrication in the wheel head. And again, this has a heat exchanger also. There you have some gauges, pressure gauges for your table system. And you have your filter here for the spindle. And this right here is a pressure sensor for the wheel head, so you will not be able to turn on if there's not enough pressure or there's not enough flow. These right here control the flow of oil. This is going to be for the wheel head moving in and out on the ways. This is the way surface for the table, left, right. And this is the oiler for the lead screw for the wheel head. This line right here, that is where the oilers up front for the table movement and the wheel head movement, and also the oil for the lead screw. It is coming out of the hydraulic tank here, so you will need to keep track of your hydraulic oil from time to time. But this is what's supplying the oil for your ways and for your lead screw up front.
So we mentioned earlier about the workpiece coming on when you bring the wheel out of home position. This selector down here is the directional. You go from reverse to forward. It's going to slow down, come to a stop, and then start back the other way.
Here we have the tailstock on the machine. This is the oiler for the quill, which you should not use very often, maybe once a day or so. This adjusts the spring pressure on the tailstock here. This locks it into place. You can see here you have your dresser that's moving in and out. And when you're going to set up your workpiece, you had to put it in that position. It's going to lock in place. And then you move your tailstock up to the workpiece. Adjust that back until the center seats in the workpiece. And then you lock it in place with that. And then you're good to go. These right here are showing the total 4 2-point steadies, 150 to 260, 6 2-point steadies, 35 to 150, and 2 of the 3-point steadies, 220 to 350. Alright, that sensor there is for vibrations. And he just moved all the little weights around to match up with 0, 120, and 240 on that round degree scale. And this is the electronic balancer here.
This is Norton. He's trying to get more information from Norton.